All right, my goal is to get you interested, up and running in using a CNC as quickly as possible. So we're going to use that as a glorified hole saw. We're going to cut a hole in this board. Go to Aspire on your design computer. Your design computer and your control computer will always be separate, or it should be. Create new file. The width and length are already there. I've taken the liberty to measure the width and length and put them in there. You'll see the X is your width and your Y is your height. I said width and length. I get it confused. They call it height in this program. Your thickness is 1/4 of an inch. We want our zero position to be the material surface, and I'll show you that at setup time. Our datum position, this is where the material starts. So with that circle, you can see where I can change it. And the workpiece red dot there changes. This is just where the tool is going to start cutting the material. In this case, it's going to start right there. Okay. And I hit OK. We're going to draw a circle right here in the middle. I'm going to hit apply, going to hit close, going to hit, now when you move stuff, you come down here to edit objects and you select that third arrow, and then you can click on the circle I just drew and move it. Okay, I love it. That's beautiful. Let's cut. So there is this little toggle, switch to toolpath commands, right up there, right there. I'm going to tap that. Drawing goes away. You can still get to it by tapping drawing. But here's the toolpaths. All right, we're cutting, so we want a profile toolpath. Our starting depth is 0, and our cut depth is 1/4, 0.25. Our tool is a 1/4 inch end mill. You can select a variety of tools. That's not the point. As this video is not going to make you an expert by any stretch of the imagination. All right, so these are all more advanced things to know. I'm going to hit calculate. And it shows you a preview of your tool path. I'm going to hit close right there. Okay. Now I'm going to save the tool path. There's that little save icon. And you want to be sure, now it says selected tool path, and if that is grayed out and your tool path isn't selected, you go to 2D view. I really don't like this 3D view. See how that's all selected? Now it is, now it isn't. If that isn't selected, it won't save. Your post processor should always say legacy 3-axis inches. This is how these are a huge list of other machines, and it's just how the machine understands the G code. All you need is this. Hit save toolpath. Now it's asking where to go. Now, we are going to put it in this computer, which is not on the internet because it is very elderly. It is elderly and a bad idea to put it on the internet. So we're going to use this jump drive. And we're going to call it test. And we're going to save, click on the jump drive. We're going to save it. Yeah, I'll replace it. Okay. My tool path is now saved on that jump drive. So I'm going to eject the drive from the computer. And move it to the control computer. Before you, okay, now, Your G-code streams via USB cable to the machine. So you don't want to take any chances. You want to take your program and put it on the control computer. I'm just going to drag that test file to the desktop. I'm going to close this. Now before you start the software, which is this Mach 3 loader, you got to have it plugged in or it'll error. So here's our machine. You have 3 cables, USB, and they're all got magnetic holders on them, so you can get the cables up off the floor and roll the machine around. You have 2 power cords. One controls the actual CNC gantry. The other is the router itself. One note about, okay, so I just turned the power switch off. When the power is off, you can move this gantry. It's best to just bring it forward. It'll make it faster to set up. Turn the power on. It won't move anymore. Gantry is active. Stepper motors are active. Now we can start ready to start our control software. Power up. Start software. Press OK. And it's going to ask another question. That's an advanced feature. Just press OK. Press reset. Reference the machine. Yes. Machine starts moving. It is learning its location in the real world. There are limit switches on this machine so that it doesn't run itself off the end of the machine. And it's very slow moving when it is referencing itself, which is why it's good to get the router head all the way up to the front of the machine before you turn it on. Almost there. And okay. Machine is now referenced. Okay. Now we need to attach our workpiece to the machine. This is the jog controller right here. You can just push and hold. It'll move the machine. There are multiple ways to attach your workpiece to the machine. I got some painter's tape on there. What's up with that? I could use these clamps. These go into the machine bed. Oops. Well, that's problem number 1. Problem number 2 is if you make a mistake in your program, you could run your tool through the hold down clamp. So I could do it that way, but we're looking for mistake-proof ways of doing this. So I've got painter's tape on the bed. I got some CA glue, otherwise known as super glue. And I have activator. This is, if you don't know about activator, oh my gosh, it just changed your life forever. Now, if you're doing this to a piece you cared about, you'd have tape on this too, and go tape to tape. Hit. There we go. That's stuck. Sometimes it helps if you give it a little path to get in there. It doesn't take much. There we go. Now we're stuck to the tape. Okay. I love CA glue. It's also cool for like, you can put cardboard on here and do a test cut without hurting your valuable workpiece. So, next thing I want to do is teach the machine where the workpiece is. We got to get the tool to that corner. So using the jog controller, I'm going to move the Z way down so I can tell exactly where that corner is. Okay, that's close enough. Now, all I care about is X and Y. So that's your width and I forget what they called it, depth maybe. All right, so you press the X, you press the Y, and it changes these numbers to 0. I have no idea why that went to black. This software is so quirky. I have the task manager down here on the bottom as a shortcut so you can quickly shut this application down. If you unplug the USB cable while this is running, it will freak out and you can't close it. So we have our X and Y 0. Next we're going to open our we're going to load our program. It says load G code. And select test. There it is. There's our circle. Now we got to teach the machine where the top of the workpiece is and where the tool is. So I'm going to turn on the smart tool. A lot of times this is already on. We're going to do smart tool setup, and it's going to say, is the spindle over the tool pad? No, it's not. It's going to tell me to move it, and I hit cancel because that is not high enough in the air for the pad to fit under. So there it is. Now, I'm gonna put this under the tool. You don't want to touch the metal while this is doing this, or it'll sense your finger and it'll think it found the smart pad and then it won't work. So, smart tool setup. Yes, it's under the pad. It touches it. It very, very, very slowly touches it. Okay. Now, move smart tool pad to home location, which happens to be right there. Okay. So it found the top of the workpiece. Now it's finding the top of the spoil board. These are totally replaceable. This one needs to be replaced. It's pretty uneven, but for learning, it's all good. Okay, I'm leaving the pad there till the job starts. Now I'm gonna hit cycle start. Click OK or press enter after tool change. So if I was putting the bit in, that would be the time to do it. Bit's already there. Hitting OK. It's gonna go down to the smart pad so that it can find the bottom of the tool. And it found it. Now it's gonna go to the starting position, and it's gonna say turn the router on and press OK. Now this has a dust shoe. After the tool change, you would normally stick the dust shoe on. And it's magnetic, it just pops on there. I'm leaving it off just for this demonstration so you can see the tool work. With a vacuum attached here, the dust collection is nearly perfect. This will be a hot mess. Turn on the router, press OK. We need more speed. did not cut that all the way through because the spoil board, well, the workpiece is not true. The spoil board might be a little uneven, but you get the general idea. That is how you turn a $10,000 CNC machine into a hole saw. Actually, it's probably more like 5 back in the day. This is a very high quality machine for its size. And, you know, if you can run this, you can run a full-size one. So it's a very cool thing. It's a wonderful opportunity to have in a school. And I just can't wait to see what people make with it.